All right, greetings everybody. I wanted to take a look really quickly at exercise 3.5. I've had some people with some confusion, and part of it is these are all math problems, and everybody looks at them and panics a little bit. So I think the first thing I want to do is I want to look at how do we set up some of this, because if we can set this up as a math problem, then I think we can set this up then into Python. And so part of it here, we need to put in and figure out what items we actually need. And so I'm going to do it in here for a sample, but we know that we need a couple of items first. So we need the initial number of organisms, and it says we're going to use those as an integer. Okay, so very cleverly, I'm just going to call those number. And so we're going to assign it a value based on what we're going to take in. So we're going to cheat a little bit and convert, because remember, everything we take in is always set up as a string automatically. So please enter the original number of organisms. Okay. So we also need the growth rate. So this growth rate is just a number that we're going to put in there. So it's got to be greater than 1. And so we haven't yet talked a lot about validating our inputs and things, but I think we can shortcut that to just rate. I think that'll make a lot of sense. And we know this one has to be a float. So in other words, it can have decimals at some point in there. So we're going to do an input. Please enter the rate of growth. And then I'm going to say must be a real number greater than 1. Now, we're not actually validating that. Somebody could put in a value that doesn't work and cause all kinds of issues for us. All right, so the next thing we need is the number of hours to achieve this rate. So this is kind of interesting, because what we're saying is, let's say we put in the rate of 2. So that growth rate over a certain number of hours, if we started with 100 little bacteria, at the end of 2 hours, we would have, and then we had a growth rate of 2 at the end of whatever time period. And so if we specified 2 hours, it would then have 200 little bacteria growing there. So we also need then to get the number of hours it takes to achieve a rate. So we could just call this rate time. And again, the variables don't matter as much as making sure that you're consistent and you're using them and they make some sense to you. So we're going to achieve this one. This one's going to be an integer. And so we're going to do an input. And again, if it makes more sense to you to take in the value and then convert it in a second line all by itself, that's certainly fine also. So we're going to get in this rate time, enter how many hours to get to, I'm not sure, how do we phrase that? To get to growth rate. Kind of awkwardly phrased and thinking on my feet here. All right, so the last one we're going to need then is how many hours we're going to allow this entire colony. If we want to think about it like bacteria growing on a slide, how long are we gonna let them go? So we know how long it takes to get to a certain size. We know what how many hours we're going to allow it to grow. And so we might call this total hours or total time. Since we're using time above, it would make sense to use something consistent. So total time. And once again, we're going to use an integer in there. So we're going to convert it automatically to an integer. Input. Be helpful if I put that in. Chunk. Please enter how long you are letting this grow. Okay, so now we have 4 values, and normally I would put in a lot of comments, and I'm kind of hurrying here a little bit, but one of the first things we need to do is we need to figure out how many then complete cycles this is going to take. So here's the problem. So I'll just sketch it out here. So say we said that we're going to allow it to run for 7 hours. But we said that the growth rate is 3 hours. So in our brains we say, oh, so it's going to be how many cycles in total? Well, we don't know this directly. We'd say 7 hours, 3 hours. So it's going to have slightly over 2 cycles. But I can't run a loop a partial piece. And we could come up with some clever mathematics. But the one that we can kind of use that we explained, and somewhere I've got a copy of it here to show you. So I just went and grabbed this chart to look at a couple of different operations. And so we're familiar with the plus, minus, times, division. There is a couple of new ones that some of you may not be used to. So the modulus is actually kind of an interesting operation. So let's see what the modulus does. So the modulus says we're going to put, well, actually let me not confuse you. So the modulus really just says this is your remainder of a division problem. But the one I'm more interested in is this idea of something called floor division. So floor division says I'm going to divide something and it rounds the result down to the nearest whole number. So in this particular case, if I had 15 divided by 2, I get the result of 7. So let me see if it'll run in this little window. We'll see. I just grabbed that as a quick chart and I hadn't played with that a lot. So it says, oh yeah. So if I do my 7 hours and 3, that's going to give me a result of 2. So 2 cycles. Okay. So taking that information, we're going to come over here and I'm going to figure out how I can get to the number of loops that I need. So to do that then, I might even just call it loops. Or if I wanted to express it a little better, number of loops. Maybe I'll express it that way. And so what we're going to do is this total time equals total time. And so it's 2 division marks divided by, and if I come up here and I get my rate time, and notice like it pulls those for me, which is kind of a nice touch. So I'm going to put in a test print just so I can print number of loops. So I'm going to run this really quickly. So click, run, and it says I've done something dumb in probably my line 2. Great. Please enter the, oh, I didn't put an enter in there. Holy cow, or an input. Well, apparently I need some coffee this morning. All right, now we'll try to run that. Please enter the original number. And this one, I'm just going to put 1 in because it doesn't really matter. The growth rate, though, is what value I'm going to use. So I'm going to say it's going to take 5 hours for the growth rate. And 5 hours. And then I'm going to say we're going to let this run 48 hours. And in that case, it would be 9 cycles. So 45 divided by 9. So we can run it with a different number. And in fact, I can go clean up some of this really quickly because that drives me crazy, but I was trying to do this in a hurry. Chunk. Okay, so now we'll try to run this again. Please enter the original number of organisms. Doesn't matter. The rate of growth really doesn't matter for this one. Hours. So we're going to say it's 3 and 20 hours. And so it should give us 6. So it slices off that remainder for us, essentially rounds it down, chunks off the remainder. And so it gives us how many times we're going to actually run a loop. So now that we got this, and I'm going to take this line and I'm going to do this because it may come in handy. So all I've done is commented it out, and it still might be kind of a handy way to do this. So now we got to look at how does this growth rate work. So here's our example. Start with 500, a growth rate of 2, and a growth period to achieve this rate of 6 hours. Assuming that none of the organisms die, this would imply that the population would double in size every 6 hours. Thus, after 6 hours for growth, we would have 1,000, and after 12 hours, we'd have 2,000. Okay. So, let's take a look at how we could create this. So, I've calculated how many times a loop. So I have a definitive loop counter or a loop number. So when I have a definitive, I tend to like to use this idea of a definitive for loop. So I can do something for, and I'm just going to throw X in there for right now. Well, maybe we'd come up with a better one. In range. So, and that range then is going to be our number of loops. Aha. So that says we're going to go from 0 to whatever this value is, number of loops. It's going to run that number of times. Great. So now we have to come up with a formula that says what is that value going to be. So we know we start out with number, right? So number up here we've used, and I know you guys can't see my hand gestures here. I just realized that. So number is this original number, and every time this loop runs, it's going to multiply times that rate. So we know how many times. So number equals number times whatever our rate is. So our rate here is whatever we input, so let's just call it rate because, we got that. That's all it does. It multiplies it that many times. So in this case, so we then need a print statement. So, and what it's looking for is a lot of times very similar. So I'm going to just do this because I want to cheat as much as I can. Print chunk. The total population is, and then we can put in number. Now, I have had somebody, well, let's try and run it and show what happens first. So we're going to run it. So our original case here, so 500, a growth rate of 2, 6 hours, and then we said 12 hours, if I remember right. Chunk, and it says, hey, it's got it as 2,000. All right, so we've created something, and yours will look different. There's a lot of different ways to do this. This is just one possibility of a really quick way to do it. So let's see if it actually works. So we'll grind it here and run the checks. So it actually passes in information, and it gets an answer out. There can be, so if I want to show that total population and I want to show it, I can alter it a little bit. I could convert it back to an integer if I wanted to, so it would drop the decimal notation. But we're not going to have partials of an organism. So Is this realistic? So one of the problems with this is, have we ignored any growth that happens? Yeah. So if we were looking at hour 13 and we put in 13 hours of growth, we wouldn't come up with a number. We only look at it for a complete cycle. And the math gets a little harder if we start adding some other pieces in there. So this is my take. So you can do it any number of ways, and there's a lot of other ways you could do this, quite frankly. The hardest part in this case is actually calculating this, and you could certainly do it with some mathematical formulas and not use a loop. So I'll give you a hint there. There's some other ways that you could do that. All right, thank you for your time.